All right, welcome to this lesson about the circumscribed angle theorem. This is Mr. Giovanelli at Agua Fria High School. Your learning target today is to calculate the measurement of a circumscribed angle, which you'll see fits in right into this standard where you've learned a lot of these theorems by now. So this is one of the last ones that you're going to learn is the relationship of a circumscribed angle. Okay, first let's start with the warm-up on something that you've seen up to this point. If we were going to calculate the measure of angle A, this angle is being formed by two secant lines. So this is a secant line, and then this is also a secant line. So this is sometimes known as the secant-secant angle theorem. And you've learned this already. To calculate the measurement of angle A, what you're going to do is you're going to take 1/2 of the difference between these two arcs. So you're going to subtract, in other words, these two arc measures and divide that by 2. So you're going to get 1/2 of 70, which is going to be 35 degrees. If you like divide 70 in half. So that's when you have two secant lines forming an angle. Okay, so what is the circumscribed angle theorem? Well, first let's define what that is. A circumscribed angle is this angle here, angle C. And this is an angle that's formed by two tangent lines. So unlike the warm-up where you had two secant lines, this is when it's formed by two tangent lines. They're only touching the circle in this one single place. So you'll sometimes have this called the tangent-tangent angle theorem. So let's see how it looks. How would we calculate this angle? So here's another circumscribed angle. By the way, we call it circumscribed because this angle is like circumscribing. It's going around the circle. But how would we calculate angle B? Well, it's going to be very similar to what you saw in the warm-up. Angle B could be calculated by taking 1/2 of the difference between these two arcs. So if we do 240 minus 120, and we take 1/2 of that, 240 minus 120, that's 120. So 1/2 of that is 60. So angle B is 60 degrees. So notice it's very similar to what you already know about secant-secant angles. Okay, let's discuss a little bit before we practice, like why does this work at all? Like why, we always want to know the reasoning behind things. So why would we be able to figure out this angle measurement? Well, let's kind of explore this with a central angle drawn. So notice that this angle, 100 degrees, is the central angle. So I want to remind you about a couple different things. So here's the first thing. You could figure out this arc measure is also 100 because it matches the central angle. Okay, and then you could figure out that this other arc, this major arc here, would be the rest of that 360. So this would be 260. Okay, so let's leave those numbers there. This is just based on other things we know. Let's also add one other idea that we've already seen. If this is a radius, that means that this is a 90-degree angle going to a tangent line, and that means that the same thing's happening over here. Okay, so let's take a look now. What I'm highlighting here is a quadrilateral. All quadrilaterals have to add up to 360 degrees in their angles. So we have 90 plus 90 plus 100. So 90 plus 90 plus 100 is going to give you 280. If you subtract that from 360, you're going to get 80. Okay, so this angle measurement here, angle B, is 80. Now watch how we can apply that to the theorem that I just taught you on the last page. I can show you that angle B would be 1/2 of 260 minus 100. Watch how we're going to get 80 again. 260 minus 100, that's 160. 1/2 of 160, boom, 80 degrees. One really important kind of quick trick here, something kind of cool that you might notice already. This angle, the circumscribed angle, will always be supplementary with this arc, meaning these two will always have to add to 180 degrees just based on what you saw there. That works all the time. Okay, let's apply this. Let's practice this. So I'm going to do this the long way, and then as we go further, I'll kind of take some shortcuts. But if we're looking at this, we could say, all right, we're given the 70-degree arc. So if we wanted to figure out the rest of it, we do 360 minus 70, so that's going to be 290. And now I can say angle X equals 1/2 of 290 minus 70. So 290 minus 70, that's going to be 220. And so half of 220 is going to be 110. Totally fine to do it that way. Now, if you're looking for a little shortcut, if you recall what I said on the last slide, these two values have to be supplementary to each other. So that means I could have also just done 180 equals X plus 70. And so if I subtract 70 from both sides, we would get X equals 110. Little less work if you can see the relationship that way, but both ways work. Okay, let's advance it a little bit more now, where they're kind of making us figure out the information a little differently. So here we want the measure of angle A. Ooh, I don't know why that came out as a question mark. That should say angle A. Sorry about that. Okay, we want the measurement of angle A. We're given this angle here, 30. It's an inscribed angle. Now, applying some past knowledge, the central angle is going to be 60. Okay? Again, applying some past knowledge, if the central angle is 60, then this arc that it forms is also 60. And guess what? I'm going to use the shortcut here. That means angle A, so A plus 60, have to equal 180. Based on what we've learned, those two values have to be supplementary. So if we subtract 60 from both sides, that means angle A is going to be 120 degrees. Okay, let's do another one where, again, we're just being asked to find the information in a little bit of a different way. Again, that should say angle. I don't know why my angle symbol came out weird there. So let's find the measurement of angle 1. Now here we have an inscribed angle with no central angle given, but I still know that this arc is going to be double the measurement of that angle. So this is going to be 132 degrees. That's 66 times 2. So again, applying what we know, angle 1 plus 132 is going to have to equal 180. So if you subtract 132 from both sides, the measurement of angle 1 is going to equal, what's that, 48 degrees. There you go. It's not too difficult if you know what to look for. All right, let's do one final one here together. And now we're going to just use a little more algebra to determine the value of X. I'll do it the long way, and then I'll show you a real quick way we can do it. So if we're looking at this, if we go through kind of like the first way I taught you this concept, the circumscribed angle is going to be this big arc, so 360 minus X, subtracted by this small arc, and then half of that value, right? So I'm just going to say times 1/2. All right, and we can solve for X just based on this equation, just using that concept. The bigger arc minus the smaller arc times 1/2. All right, let's go through it real quick. So multiply by 2. That'll get rid of our 1/2. So now we have 160 equals, combine like terms here on the right, 360 minus 2x, because it was minus x minus x. Okay, let's isolate the x variable. So subtract 360 on both sides. So now I have negative 200 on the right equals negative 2x. Divide by negative 2. So based on this, x is going to equal negative 200 divided by negative 2. It's going to give us positive 100. Okay, totally fine way to do it. Now, maybe you saw this already. If you go back to the very beginning, what did we say about this value and this arc? They have to add up to 180. So 80 plus what number is 180? It's 100. If you see that relationship, you're going to get to the answer much quicker. Okay, that should do it for you on circumscribed angles. You ready for the exit ticket? Best of luck to you. Have an awesome day.